Lesson 23, Important Characteristics to Describe. Example 4. Use appropriate descriptive statistics methods to describe the important characteristics of the box office worldwide gross in dollars for the movies in the movie database sample. So to describe the important characteristics of data, we need to focus on the three main aspects: the distribution, the central tendency, and the dispersion of the data. The data in this example was the worldwide gross for the movies in the movie database sample. So looking at the results here, the data is obviously quantitative. And we could use our TID4 calculator to help calculate the descriptive statistics results that we need. To enter data, we press Stat, Enter, to enter the list editor, and then we could choose any list we want to enter in the data. If we have old data that we want to clear out, we can use the arrow button to navigate up to the list name we want to clear, in this case L1, and then pressing Clear, Enter, clears out list 1 of old data to make room for new data. Now I've already taken the time to enter the worldwide gross data into the calculator. To recall it into list 1, we could just navigate to the list name by pressing the up arrow to highlight L1. And then to see the lists of data that are stored in my calculator, I press Second, Stat, to bring up all the lists of data. And using the arrow button, I can arrow down till I find the data I want. This data I labeled MWG for Movie Worldwide Gross. Press Enter to select. So now it tells me that list 1 will now equal the data that's been entered into MWG, Movie Worldwide Gross. Press Enter, and here's the data. Since these data values are much too large to show up in just this part of the display, they've automatically written the data in scientific notation. So now that we have the data entered in the calculator, it's obviously quantitative data, but we need to see if we have any outliers. So to determine if there are outliers, we need to calculate the standard score for the data values. One way to do this is I can arrow over to list 2 by using the up arrow to highlight the list 2 name, L2, and then type in the standard score equation by pressing left parenthesis, and then the data values. Well, here all the data values are in list 1, so second 1 displays list 1, so there's my data values in list 1, and then subtract the mean for all these data values in list 1. We can calculate the mean for list 1 by pressing Second and List and arrow over to Math. And one of the math operations we can do to list is calculate the mean. You could either press 3 or arrow down to put the cursor on the 3 next to the mean and press Enter to select. Then we have to tell the calculator what list we want to calculate the mean for, and we're doing the data here in list 1. So second 1 brings up list 1, close parenthesis. So now it'll take all the data in list 1, subtract the mean for list 1, and then another right parenthesis to close off the numerator. And then we divide that deviation by the standard deviation. To calculate the standard deviation for a list of data, we can press Second, List, arrow over to the right twice to the Math menu, and the standard deviation is the 7th option down this menu. We could either get to it directly by pressing the number 7 or arrow down and placing the cursor next to standard deviation and press Enter to select. So the STD-DEV, short for standard deviation, and then we got to tell the calculator what list the data's in. It's in list 1, so we press Second, 1, and then right parenthesis to close. Pressing Enter, the calculator will now calculate the standard scores for all the data in list 1. And now we want to look for outliers. Outliers are data values that have standard scores that are either -3 or lower or +3 or higher. Here's a standard score that's a positive 4.75. This is obviously an outlier because a standard score of 4.75 is definitely higher than the +3 or higher. So we have an outlier in this data. So The appropriate descriptive statistics methods that's used when we have quantitative data with outliers is to calculate the median to measure the central tendency and to calculate the median absolute deviation to measure the dispersion. The distribution of the data can be displayed by using any of our appropriate graphical descriptive statistics methods, such as a distribution table, histogram, or stem and leaf plot. So we could use the TI-84 calculator to help us calculate the median, median absolute deviation, and a histogram. So we need to calculate the median and the median absolute deviation. To do this, we could press Stat, right arrow over to Calculate, press Enter to select, and then we entered this data into list 1, so I press second 1 to display list 1, and I press Enter. The median is found on the second screen, so I down arrow till I could find the median. So here the median is $338,726,582. And then to calculate the median absolute deviation, we then need to first start off by calculating the median by pressing second, list, right arrow over to math. The median is the fourth one down this list. Select it. And it's the median of the absolute values of the deviations. We can find the absolute value by pressing the math button and then arrow over to the num menu for number. And the first one on the list, ABS, is the absolute value of the deviations, which is the data values, which are in list 1. So second 1 brings up the data values. Subtract from the median is the point of reference that's used in the median absolute deviation. So again, to find the median, we go second, list, arrow over to math, and select number 4 for the median of the data in list 1. So we press second 1, close parenthesis on the median, close parenthesis on the absolute value, and close parenthesis on the final median calculation. Press Enter. And the median absolute deviation is $118,155,688.50. Now to construct a histogram for this data, we'd press second, y equals. To get to the Stat Plots menu, press Enter to select plot 1. It's already turned on. It's already set to histogram. And the X list is list 1, where we have our data. So there's no need to change anything here. Now we just need to define the window. So we press Window. Now we have to establish the X-axis and Y-axis for the histogram. So the X-min would be our minimum value, which needs to be either at the minimum data value or somewhat before. And the X-max is either the maximum data value or somewhat after. And the X-SCL, or scale, is the amount by which we're grouping by on the X-axis. So the minimum worldwide grossing movie we had in our sample was around 205 million. So a good number to start with a minimum here would be 200 million. So that'll cover the minimum. Enter. The maximum movie was the one with that was the outlier, and it was at 1,843,000,000. So a good number to start here might be 2 billion. Enter. And then the X scale, well, since the standard deviation was somewhere around 294 million, a reasonable number to use for our scale would be 250 million. Enter. The Y-min and Y-max and the Y-scale define the Y-axis, and on a histogram this is the frequency. The minimum frequency is always 0. The maximum frequency we don't know till after we construct the graph, but a good estimate is the N sample size. In this case, there were 60 movies in this movie database sample, divided in half, which is 30. And going from 0 to 30, it seems reasonable to count by 5s. Enter. Now we could press graph to get our histogram. If we press trace, we can see each of the resulting bars in the histogram. Notice the first bar has a frequency of 35, which actually goes beyond our Y-max, which was 30. So we're going to have to go and readjust that. As you can see, the top of this first bar in the histogram is cut off. So we need to go back to Window, and I'm going to arrow down and change the Y-max to 35 so we can cover the maximum frequency. Now, pressing graph again, it redraws the same histogram, but now on this new scale where we completely cover the range from 0 to 35 on the frequency axis. So looking at the resulting histogram, we could see the pattern displayed by the data. It's definitely lopsided. That is, the highest frequency value occurs way off center, and the data values extend much further in the positive or increasing direction than they do in the negative or decreasing direction, thus resulting in a description we call a positively skewed shape distribution. The TI-84 calculator also calculated the median for us. MED was equal to $338,726,582. And we used the TI-84 calculator to help us calculate the median absolute deviation, or MAD, and it was equal to $118,155,688.50. Now each of these three results can then be used to describe, in words of the problem, a useful description of the important characteristics of this sample. The box office worldwide gross for the movies in the movie database sample has a positively skewed shape distribution, with a median of $338,726,582 and a median absolute deviation of $118,155,688.50.